Good day and welcome to our class. Our today's topic is ellipse. This is shape of ellipse. It looks like this, an oval shape like this. This is circle. It's not circle. So this is ellipse. It looks like an egg shape, but egg is solid. This is a plane. Now, inside this ellipse, we call this one, this V. We call them the vertices of the ellipse. This is one vertex, that is the edge. This is another vertex, and this is the center. This F1 and F2, they are focus that we define in parabola. Also, this is a point that is moving on this ellipse. If this point, one thing about ellipse is that if this point moves to this place, if you add these two together, let's say it's no more in that place, it has moved to this place. If you add these two, let's say we have the point P here now. If you add these two and you add these two, they always be the same thing. So that will lead us to the definition of ellipse. Now, an ellipse is the locus of point. This is the point, this point that is moving in a plane in such a way that its distances from two fixed points called foci. These are the two fixed points, F1 and F2. Singular is focus, while the plural is foci, F1 and F2, is constant. That is just what I was explaining. That is constant there means that if you add these two distances together and these two distances together, they will be the same thing. Even point P, this point P, moves to this place, and you add the distances from these two foci together, it will still be the same thing as when you add these two together. That is what they say the thing is saying, and it's constant. It will always be the same thing. So what are the things we consider inside ellipse? We consider what we call major axis. This long one is the major axis. This is A, this is another A. There's a minus here. This is minus A. We call it major axis, while this one is minor axis. If it is ordinary A, that will be semi-major axis. This is semi-minor axis. Also, F1 and F2, that is focal length. These two, we call them focal length. So we should now know that the vertices are V1, which is A, 0, V2 minus A, 0, V3 B 0, B, while V4 will be 0, minus B. So that means this one, it should be minus A, 0. That's our, let me say, V1 and V2, V3, V4. So these are the vertices of ellipse. What are the other things we normally find inside ellipse? The other thing is we normally find what we call eccentricity. That eccentricity is simply defined as the ratio of the semi-focal length to the semi-major axis. That is, eccentricity, we use E to represent it, is the ratio means division. That is, this is semi-focal length because focal length is 2c to semi-major axis. Major axis is 2a, then the semi will be a. So this is eccentricity, c over a, which must be less than 1. Normally, if they say that eccentricity of any conic section, you know, in conic section, which we started in conic section, we have what we call circle, which we have treated. We have what we call parabola. We have what we call ellipse. And we have what we call hyperbola. The eccentricity of circle is 0. Eccentricity of parabola is 1. That is why I don't consider them. But in ellipse, eccentricity is less than 1, and also eccentricity is greater than 0. So the eccentricity of hyperbola is greater than 1. Now, what do they really mean by eccentricity? Normally, to any conic section at all, either circle, parabola, or all this, any conic section at all, we normally define it as the locus of point which have a certain ratio between a fixed point and a fixed line. That fixed point is called focal length. That fixed line is called directrix. So that the focus that we have been saying. So that constant ratio is what we call ellipse. So this is what we are trying to say here in written. Any conic section can be defined as the locus of point whose distances to a point. The point is called focus, and a line, that line is called directrix. They are in constant ratio. So the ratio is called eccentricity. So the eccentricity of the ellipse will now be less than 1, and it has been defined as the ratio of the semifocal length to the semi-major axis, which is C over A. Now let us now move to equation of ellipse. Consider equation of ellipse centered at origin. Let's consider this ellipse. This is origin O. If you see the life movement of these two lines, F2P and F1P, you will know that the distance between them, distance, if you add them together, it will be equal to 2a. It will be equal to the length of the major axis, which is the constant we are talking about. So from that place, we have known that if you use distance between 2 points for this, we should be able to have x minus, if you use for these two, we should be able to have s minus c squared plus y squared plus pf2. That should be s plus c squared plus y squared. So that will give me 2a. So we now need to simplify this. So but I will not need to show you those ones. So when we finally simplify, we are going to have this. Let's start it. We are going to have this by Pythagoras Theorem. If you consider this OF1 and V3, if you apply Pythagoras Theorem, we will see that b square plus c square is equal to a square. And from that place, if you make b squared is a formula, you will see that it is equal to a square minus c square. If I substitute it in this star, equation of ellipse, will now become s squared over a squared plus y squared over b squared equal to 1. Where we have this, where we have b squared is equal to a squared minus c squared. So we normally use these two when we are dealing with equation of an ellipse. So we use this second equation to get our c, the value of c. And in the case whereby this thing is interchanged, that is, it's not more like this, it's not like this, the major and minor axis interchange, then it will turn to s square over b square plus y square over a square is equal to 1. So this one too will be interchanged. Okay, let's consider example. This is a question given the ellipse this. Find the length of semi-major and semi-minor axis, the foci, the vertices, and the length of semi-latus rentum. Now, we are given this. We need to express it in terms of s square over a square plus y square over b square is equal to 1. How do you do that? You only need to divide both sides by whatever that is here. So that we are going to have s squared 9 over 225 plus 25y square over 225 is equal to 225 over 225. So we have divided both sides by 225. So at the end of the day, we are going to have s square. So 9 over 225. So will give us 25. So this is 25 plus y square over 25 divided by this will give me 9, and this is 1. So it's now in form of this. So you see that this one is greater than this. So in that case, I can say that my a square is 25. I can say that my b square is 9. So I can get my c square from this place. My c will now be a square minus b square. So I can say that my c square is equal to a square minus b square. That is 25 minus 9. 25 minus 9. So from that place, my a is plus or minus 5. My b is plus or minus 3. And my c is plus or minus. We need this minus this. That should be 16. And square root of 16 is plus or minus 4. So what are the things we are looking for? We are looking for length of the major axis, semi-major axis, semi-major. Semi-major will just be A because major axis is 2A. So semi will be half of it, which is A. And our A there is, we pick 5. So semi-minor will be B. Our answer is, and our B is 3. And finally, okay, we are still having another one, foci. The foci are f1, which is c, 0, is being given in the diagram, and minus c, 0. So we have known our c to be 4, 0, and then minus 4, 0. You have to find the vertices. The vertices, which are a, 0, minus a, 0, 0, b, and then v4, 0, minus b. So we have known our a. A is 5, b is 3, c is 4. So this is 5, 0. So this should be minus 5, 0. The third one is 0, 3, and the last one is 0, minus 3. These are the vertices. So the vertices are here. And the last one, the final one, semi-latus rectum. If they say that latus rectum is given as 2b square over a, if they are not saying that we are looking for semi-latus rectum, so semi-latus rectum will just be b square over a. And our b square is 9. This is 9 over 5. This is semi-latus rectum. Suppose we have to find the eccentricity, although it's not given. Let's assume that we have to find the eccentricity. If I could remember, eccentricity is given as E is equal to C over A. So what's our C? Our C is 4 over our A is 5. So 4 over 5. This can be 0.8. It's less than 1. So this is the eccentricity of this ellipse. Let's take another example. To find the ellipse, if C is 3 and semi-latus rectum is 5. So we know that semi-latus rectum is b square over a. I will compare with this, that with 16 over 5. So you will see that b square is 16 and a is 5. So we have known our C. So the equation of parabola is, the ellipse is s square over a square plus y square over b square equal to 1. This is s squared over a square. Our a square is 25 plus y square over b square. Our b square is 16, which is equal to 1. So this is the equation of the ellipse. Let's take another example. 3. Find the equation of ellipse passing through this point, and focus is this. So we know that focus, so solution, we know that for focus is given as c, 0. Definitely our c is equal to 6. So we should first take note of that. Now let's come to the equation. Equation of ellipse, we know that is given as x square over a square plus y square over b square equal to 1. But they said the equation passes through this. What they mean is that if they say that this equation passes through a point, that means we can substitute the point as x and y. This is for x, this is for y. So it will be the same thing as 5 root 3 squared over a squared plus 4 square over b square equal to 1. Now we know that 5 square is 25. Root 3 square is ordinary 3. So 25 times 3 will give me 75. And if we cross multiply, so this one should give me 75 b square plus 16 a square equal to a square b square, because 4 square is 16, 16 times 8. We are cross multiplying like this. B square times this plus 4 square times this is equal to, we'll cross multiply to a square b square times 1 is a square b square that is there. Now let's come back to this c. We know before that from what I gave you here, that b square is equal to a square minus c square. So we can as well say that c square is equal to a square minus b square. So that means a square minus b square is equal to c square. Our c is 6, so c square will be 36. So we can take care of this. If you make a squared the zero formula, it will be 36 plus b square. So let's substitute a square here, so that we have 75b square plus 16 into our a square is now this 36 plus b square equal to b square into this our a square. Our a square will be representing 36 plus b square, so that at the end of the day we are going to have, after I've expanded it, I got this. So from that place, if you rearrange, we should have b raised to power 4. This is b raised to power 4. So we rearrange this one too. This is 75, and this is 16, and this is 36. 75, 16, 30. When 16 comes here, it becomes minus 16. That will be 20b square. And the 20 will subtract 75. That will be minus 55b squared. And this one comes to, we have minus 576 is equal to 0, which can be written as b square all squared minus 55b square minus 576 is equal to 0. So if you solve the quadratic equation for b, you will find out that b square is equal to 64. We don't need the rest. So if I have known b square to be 64, then I can know my a square. You need to solve the quadratic equation. If you use minus b plus or minus b square minus 4ac over 2a, so you should solve this. We don't need the second one is negative, which we don't need. So the only one we need is this. B square is 64, and we have said here that a square is equal to 36 plus b square. So I can now say that a square is equal to 36 plus b square, which is 100. So I have known my a square and I have known my b square. So I can now say that the equation becomes x square over 100 plus y square over 64 equal to 1 is the required equation of ellipse. Now, we have considered ellipse when the center is at origin. Now let's consider ellipse when the center is normal at origin. We are now considering when the center is normal at origin. So what will happen? This is the origin here, that is the middle. This is the origin here. This is the origin and this is the center. It's not more there. So the vertex will shift away to point S1, Y1. So the equation of the ellipse will now be like this, because it was formerly like this when the center is at origin. When it's not at origin, it's not at origin. So the equation of the ellipse is now this form: S minus S1 square and this. Also, the vertices and the foci will change. It will change to this. So these are the vertices and these are the foci. Let's take example on this. Write the ellipse this in its normal form. Hence, find the foci and the vertices. Now, how do you write it in its normal form? We call it canonical form. We take x to x like this. We rearrange. We bring x to x. We take y to y. I will take the constant term to the other side, which is minus 36. When this plus 36 gets to the other side, from this place, 4 is common. So this is 4 into x squared minus 6x plus this one. 9 is common here too. This is 4y equal to minus 36. After you have done this, the next step now is you express this you express it in square form. That is, you use completing the square method. How do you do that? You add half of square of this, square of half of this to the equation to make it complete square. That is, half of 6 is 3. You add 3 square to it. Okay, there is 9 here. Half of 4 is 2. So you add 2 square to it. And don't forget, whatever you have added to this left hand side, you have to add it to this right hand side. So what I've added to this side is 3 square, but there's 4 outside. So it is 3 square times 4. That is 36. Also, what I've added here is 2 square times 4. Is still 2 square times 9 is still 36. So this side will now become, if I complete the square, I have s minus 3 squared plus 9 into, this one will give me y plus 2 squared equal to, this is gone, it's 0. All we have left is 36. So we need to divide both sides by, because in ellipse this side must be 1. So I'll divide both sides by 36 like this. So that at the end of the day, I'm going to have s minus 3 squared over, this should be 9, because 4 divided by 36 is 9. This one too is y plus 2 squared over 4, because 9 in 36 is 4. 36 over 36 is 1. So this is canonical form or normal form of equation of ellipse. If you compare it to this, s minus s1 squared that I wrote the other time, plus y minus y1 squared over b squared equal to 1. So you see that it's an ellipse. From that place, I can quickly deduce that a squared is 9, a is 3. I can quickly deduce that b squared is 4, b is 2. But we know our c. We know that our c square is a square minus b square. This is 9 minus 4. That is 5. Therefore, c is equal to square root of 5. Also, if you compare, you see that our x1 is 3, but our y1 is minus 2. So I can quickly say that my s1 is 3 and my y1 is minus 2. So with the help of all this, we can find the foci and the vertices. So you have known all this, then I can find the foci. So the foci will now be these are the formulas. C plus x1. Our C is root 5. Root 5 plus our s1 is 3, comma y1. Our y1 is minus 2. So if you do the same thing, this is minus root 5 plus 3, comma minus 2. So we are done with the foci. Now the vertices. So the vertices will be s1 plus a. Our s1 is 3 plus our a is 3 as well, comma y1. Our y1 is minus 2. This is 6, comma minus 2. So we just need to substitute everything in this place inside these formulas, so that the other one to be 3, comma 3 minus 3, comma minus 2, which is 0, comma minus 2. So x1 is 3 minus 2 plus b. Our b is 2. That is 3, comma 0 and 3, comma minus 2 minus 2. That is 3, comma minus 4. So these are the vertices. The vertices of the ellipse. Another concept is equation of tangent and number to ellipse at point s1, comma y1. So we are familiar with what we call tangent and number. Let's say this is an ellipse. If you have a straight line that touches this ellipse at one point, is tangent, while a perpendicular line to it is a number. So we want to find the equation of ellipse, tangent and number to ellipse. So the equation of tangent to ellipse is given as this, while normal is given as this. We know what our A means and what our B means. So let's take example. When we want to find equation of tangent and ellipse, what mostly important is a square and b square that we must find. S1 and y1 will be given automatically. The example, find the equations of tangent and number to the ellipse at this. Okay, I did not give the ellipse. So the ellipse is s squared. Let's consider this, plus 4y squared. Let's say it is equal to 8. So this is the ellipse. So solution. So the ellipse is given as this. In order to know my A and B, we first need to divide both sides by 8. 1 must be here, so that this one will become s squared over 8 plus y squared over 2, because 4 divided by 8 is 2, is equal to 1. From that place, you will see that your a squared is 8, the one under x. Your b squared is 2. So I can now find the tangent. Tangent at minus 2, comma 1. So this is our x1, this is our y1. Remember, the formula is here. So the formula is x1 over a square plus y1 over b square equal to 1. So this is s times s1. Our s1 is minus 2 over a square. This is our a square, which is 8, plus y times y1. Our y1 is 1 over b square. Our b square is 2 equal to 1. Then we don't need to simplify this, cancel this. This is 4. So when we simplify it further, so finally I don't need to do that for you. You should be able to get 2y minus x is equal to 4. So that will be the equation of the tangent. Y for normal, you say is y minus y1 over s minus x1 equal to a square this, b square this. This is y minus y1. Our y1 is 1 over x minus x1. Our x1 is minus 2. It will make this place to be plus 2. And a square, our a square is 8. So this is 8 times y1 over b square. Our b square is 2 times this. If we divide this by this, we should be able to get minus 2. So what we are going to have there, let me manage the thing here, will be y minus y1 over s plus 2 is equal to minus 2. At the end of the day, if you simplify, you should get y plus 2s is equal to minus 3. So this is the equation of the number, an equation of tangent to this ellipse at this point. Now another example. At this point on this ellipse, drawn is a tangent to the ellipse. Find the area of triangle that the tangent line forms with the axis. The first thing is that we need to know what this point means, and we know what C means. Now let us first write this in its canonical form. We divide both sides by 1600 so that it will be 16. Okay, let me write it directly. This should be 100. 16 divided by 1600 plus y square over 25 divided by 1600 should be 64 is equal to 1. So from that place, I can know my a square to be 100. I can know my b square to be 64. Definitely my c square will be 100 minus 64, which is 36. Therefore, c is 6. So I have known my c. So what we are now saying is that a tangent line is drawn from, this one is not c, so this is c. But we have found out that the c they are talking about is minus c. So therefore, point A, which is minus c, comma 0, has become minus 6. Minus 6, comma k, not comma 0, minus 6, comma k. And we know that this point, because a point on this ellipse simply means that this point passes through this ellipse. So we need to substitute it. This will represent my s inside this ellipse, and this one will represent my y. So in that case, I will have 16 into minus c square plus 25. Our y is representing k, so we have 25 into k square, which is equal to 1600. So this one is now very easy for us to do. So this is 576 minus this minus this. Finally, if you find it, divide, simplify, and everything, we should have 32 over 5. So that is our k. So we have known our k. In that case, our c minus c comma k has become minus 6 comma 32 over 5. A tangent line is drawn from this place. How do we find the tangent line? We come to this place. We use the equation of tangent. This is x1 over a square plus y1 over b square equal to 1. This is sx1. Our s1 is minus 6 over our a square is 100 plus y1. Our y1 is 32 over 5 divided by b square. Our b square is 64 is equal to 1. So this is the equation of the ellipse. This is the equation of the tangent. So at the end of the day, the equation of the tangent, when we divide it, we should be able to have x divided by this one minus 50 divided by 6, because 2 can go, 50 divided by 3, because 2 can go. Also 32 in this is 2, so this one too, we should be able to have y divided by 10 is equal to 1, because this cancels this, and the 5 times that 2 will give me 10. So this is the equation of the tangent, which we write in a straight line form. You remember I gave you something like this: x plus a, y plus b is equal to 1. This is the coordinate of the axis. So my coordinate of the axis, if I decide to draw it, this is the ellipse. This is the focus, which is minus 6, 0, and this is the point of contact here. This is minus 6, k. So we got k to be 32 over 5. This place is our x, this place is our y. That is this place. This is our x, this is our y. So this place should be minus 50 over 3. This place should be 10. So they asked me to find area of this triangle. So it's very easy for me to find. It's a right angle triangle. Therefore, the area is half base times height. This is half times. This is the base. The base is 50 over 3 times the height. The height is 10. So if you simplify everything, so this should give me 250 over 3 units squared. So that will be the final answer. Let's take example 7. At the intersection of this line s plus 12y equal to 20, and the ellipse this s squared plus 6y squared equal to 80, drawn are the tangents of the ellipse. Find the angle between these two lines. B. Find the area of triangle these lines forms. What are the lines? This one and the two tangent lines that are drawn from their intersection. How do we start? We first solve this one simultaneously to know the point of intersections. So solution. So you go and do this yourself. Left as assignment. You should go and do it yourself. It's an assignment for you. However, let me show you the solution. So this is the solution here. As you can see, we solve this simultaneously to get this. So this is the ellipse. Also, we have the tangents here. The first question, second question. Another important one which I want you to learn. It's another important one I want you to learn how to solve. It's also an assignment, but learn it. Find the positive value of k, for which this line that is parallel to this is a tangent to this ellipse. That is, this line is parallel to this. So this is the line we are talking about. But since they say that it's parallel to this, I will look for the gradient of this line. So the gradient of this line will represent my m. Immediately, I will have known what my m is, which is here to be minus 2 over 5. So it is now value of k that we are looking for. I will now substitute the value inside this equation. I will substitute y inside this equation. So it will form a quadratic equation like this. To form a quadratic equation, this is a quadratic equation. But they said that line, this line we are talking about, is tangent this line is tangent to this line, this curve. Its tangent there simply means that it must touch the curve at one point. I will now use the equality law in quadratic equation. The equality law, which says that if the roots are equal, then we have that b squared minus 4ac is equal to 0. I will use this. I know what this means in quadratic equation. I will use it. That is what they mean. So this is my a. My a is representing 9. My b is representing minus 20k. While the whole of this is my c. So I will use this. So at the end of the day, your k will come out.